This conference will now be recorded.
Hello everyone. Good morning, good afternoon, or good evening as per your time zones and locations. So let us continue with today's topic. Now, in the last class, we have done with very important filter commands till cut, set, IO command, T command, and IO redirection, etc. Today, we are going to start with find command. Probably today we are going to finish the basics of Unix, and tomorrow onwards we are going to start working with Linux. Right. So what is this find command? See, find command will allow us to find anything, a file or a directory in the system. Like normally in Windows, we do search, right? For example, if you want to search anything, you just go to Windows tab, and over here you can see there is a search option. So in that search, if you write anything, it is going to search something for you and it is going to display out. Same thing in Linux environment also, we can find or search anything with the help of find command. Now you can search whatever you are looking for with different options. Like you can search a file by its name, or you can search a file by its inode number. What is that inode number, guys? Every file will get an index node number. Index will tell the file, or index will tell the search that exactly where on the disk this file is kept. It's like an index page what you have in your book's first page, which topic is available on which page number. Same way over here also, this particular thing will tell you that this inode number is available and that particular file is kept at which place. Then the type. See, type can be the nature of the file. Is it a normal file or a directory or a link file, etc. Then you can also search a file by its username. Username is nothing but who is the owner of the file. Or you can search a file by its group name. See, you might be aware up till now that a file belongs to at least someone who's called as the owner, and it is also belong to a group, right? So we know this particular concept. Whenever, let me log in into our system and let me show you that. Hopefully our Linux machine is up. Now I'm logging into it. So you see, when I say ls or ls-l, you will find that if a file start with hyphen, it's a normal file. If it is starting with D, it's a directory. If it is starting with L, it's a link or shortcut file, right? Same way here it is telling you who is the creator or owner of the file and it belongs to which group. So you can search a file by its username or owner name, or you can search a file by its group name, right? Whatever it might be. So how can I use this find command to search anything in the system? So we will start by typing find, and then you have to mention where you are looking this file. See, you can search that file in any folder, any location of the system. You can search it in var, OPT, TMP, home, whichever location in the system you want to search, you can search the file, right? Suppose I'm looking this file in entire operating system. I don't know where it is exactly. So if you are looking it in the entire operating system, then you have to go with forward slash. Forward slash means root, and root is the topmost directory, right? This topmost directory contains everything. Whenever you want to search anything in the entire operating system, search it in forward slash, because the whole operating system is inside forward slash, isn't it? The whole Unix or Linux operating system sits under forward slash. So I'm telling search in forward slash, search in the entire operating system with what option you are looking for. See, you can search a file by its name, by its type, by its creator's name, by inode number, etc. Suppose I'm looking for a file by its name. What is the name you are searching for? So let us say that I'm looking for a name called uh, SE Linux, something I'm searching out. It is just a general name I'm searching out. You can search any name of your choice. So if there is any file in the system with that name, it is going to search and give you address. So you see here there is a file, here there is a file, here there is a file, here there is a file. It is trying to show you lots of option. Now let us say that I'm looking for a file, or I'm looking for a directory or a folder with the name SE Linux. I'm not looking for all. So I want to add one more option over here, that I'm looking for a type directory. See, if you're looking for a normal file, you have to say F. If you are looking for a directory or a folder, you have to give D. So I'm telling that search me a name SE Linux. Okay, but this search should be a directory. It should not be a normal file. So now it is going to show me all that particular name, which is a directory. So this sysfs se linux, it is a directory. etc se linux, it is a directory. var lib, it is a directory. So basically you can club many things and find what you are looking for. For example, you are looking for all the link files in the system, for example. So you can say find in the whole operating system, show me the type of file which is link, right? So let me hit enter, and you see there are hundreds and thousands of link file or shortcut files that are available in the system. For example, I want to narrow my search. So you can say I'm looking for type link, but the name of that file should be bin, for example. So you see it is going to search and tell you that here is that particular file or directory which is a link file. So like that you can club multiple options and you can narrow your search, and perfectly you can get what you are looking for. For example, you are looking for a file by its inode number. See, yesterday we discussed about soft link and hard link, shortcut file and backup file. So inside it, I told you that you can have same inode number for two files if it is a hard link. So this is the inode number 17881858. Every file will have an inode number, but two files can only have same inode number if they are a hard link. So let us say that I would like to search all the files which has this inode number. Basically, there is no hard link we have created. We destroyed the hard link yesterday. But if there is any other file which is having same inode number, it will search and display over here. For example, I'll say find in the whole operating system. a file by its inode number. What's the inode number? 17881858. So all the files which are having same inode number, index number, is going to print out. So as of now, you see there is only one file with that inode number. If there is a hard link with that file, you will definitely get one more file or two more file with the same inode number. So like that, you can search a file or a directory or a link file, whatever you are looking for, you can search it with the help of this uh, find command. So find command is basically to search anything, either a file or a directory in our system, right? Fine. Now let's move ahead and let's try to discuss the most important topic, or one of the most important topic, which is file permissions. Now this you must understand very, very nicely without any confusion. I'll try to make it as simple as possible so that it may be easy for us to remember and work. See, whenever you run ls-l to see the output in your current location in long form, you see the file details will be printed. So if a file is starting with dash, it's a normal file. If it is starting with D, it's a directory. If it is starting with L, it's a link or shortcut file. But after that, we see some characters. RWX, RX, RX something. Now, what is this characters? What do we call it? Now, this particular things are called as file permissions. Now, access permissions, you can say in a simple word. Who can read in this file? Who can write in this file? Or if it is a command, can it be executed? All that thing can be controlled by that file permissions. Now let us understand that on which level these permissions will be applicable. See, file permissions can be applied on three levels. You can give permission to the owner or creator of the file, or you can give permission to the group this file belongs to. Then we have many other users and many others groups in the system which will be treated as other. See, a file can belong to at least one person, which is the owner or creator of the file, and it can belongs to a certain group, right? So owner, you can set some permission. Group owner, you can set some permission. Now, apart from this user and this group, there might be many, many other users in the system, many, many other groups in the system. So all those things will comes under others category. So you can give access permission to the user or a owner who created the file. You can give permission to the group to which this particular file belongs to, and rest of the all other users, all other groups, or all other world, we call it as others. Now, what permission you can give? You can give read permission, you can give write permission, or you can give execute permission. So over here, what you see, R stands for read, W stands for write, and X stands for execute. Read, write, execute. Like that, it is going to work out, right? So whom this permission belongs? We understood that a file permission belongs to a user or the owner or group or rest of the other. How to identify which permission belongs to user, which permission belongs to group, and which permission belongs to other. So over here, you see normally a permission is going like this. Dash, that means it's a normal file. Then you see first set of permission, R, W, X, something like that. So first permission, what you see, first three permission, it belongs to user or owner. Then next three set of permission belongs to group, and last set of permission belongs to others. So simply we can represent them as U for user, G for group, and O for rest of the other world, right? So first three permission on this belongs to user or creator. Who is the creator? For example, I'm looking for this file. The creator of this file is root user. So root user is having read and write access but no execute permission. Then to which group it belongs to? Root group. Root is also a user, root is also a group. So for group, there is no permission, and for others, there is no permission. Same way you see in the other directory, it says for user or owner, you have read, write, execute, all permission. For group, you have read and execute permission. Same way for others, you are having read and execute permission. Now you can change this permission to anything as per your requirement. You can remove all permissions from the file if you want. No permission for user, no permission for group, no permission for other. Or you can give full permissions for everyone, like read, write, execute for user, read, write, execute for group, and read, write, execute for other. So it is up to you how you want to give access. According to that, you can set the permission. But remember, you can give permission to user or creator or the group of that particular file, and rest of all the other users and other groups will come under other category. And maximum you can give three permissions: read permission, write permission, and execute permission. So what happens if I give read permission or write permission or execute permission? Let us try to understand that. See, you can apply these permissions either on a file or you can apply it on a folder or directory. So if you give R permission on a file, that means you can uh, open the file or you can read the file. You can read the content of the file. You can say cat and the file name and you can read it. If you do R permission on a directory, that means you can do ls. You can see what is the content inside the directory. You can check it out that in this directory, how many more files are there, how many more directories are there. You can check it out. Then you have W. See, W will allow people to make changes in the file. They can add more data into the file, edit the data, add more data, or delete the file. So write permission will give access to the people to make changes in the file. They can add something in the file, modify something in the file, or if they want, they can delete the file also. Same thing will happen with directory. On the directory, if you give write permission, people can add more files, more directory into it. They can delete the content, rename the content, or in fact, the total directory can also be deleted. So you see, read and write, they both have same impact on either a file or directory. Read will allow reading, write will allow making changes in the file or directory. But execute has a different role. See, on the file, it is not that much important. Execute permission is required on a file if the file is an executable file called script or a command. So if a file is an executable script or a command, then only we need execute permission on the file. So other files, generally on a normal file, execute permission is not that much important. It is only and only required if the file is an executable file. Then when it comes to directory, it is really important. See guys, remember this, that on a directory, If you don't give execute permission, then nobody can enter into the directory. If you want to say cd and the directory name, you want to go inside the directory, then the directory should have mandatorily execute permission. So nobody can go inside the directory without execute permission. So execute permission is really important for the directory, but on the file it is only and only needed if it is a script. So remember three permissions: read, write, execute. On which level? User level, group level, or rest of all other users or other group, which is called as others. Now, how can I apply these permissions on a file or directory? See, to apply these permissions, there are two methods what you can use. Symbolic method, which is UGO. U stands for user, G stands for group, and O stands for others. Or you can go with second method, which is called as absolute method, numbers. What is that numbers and all? We will discuss in a short while. First, let us try to talk about symbolic method. See, when it comes to symbolic method, we use the command chmod. Chmod stands for change mode. Then you have to say for whom you are modifying. Whom in the sense you have to give U if it is user, G if you are changing for a group of that file, or O for rest of the other world, right? Then plus is for adding the permission, minus when you are removing a permission, equals when you are totally modifying the permission. So if you want to just add a single permission, you can go with plus. If you are removing a permission, you can go with minus. Or if you are totally modifying the permission, then you have to go for equals. Okay, all right. So let me show you how we can apply these permissions. Let us say, guys, I have a file, and on the file, I'm looking for this permission. For owner or creator or user, I want it to have read, write, execute permission. For group, I want it to have read and write permission. And for rest of all other worlds, I want read permission. So these are the three set of permissions I'm looking for. For user, one set of permission. For group, one set of permission. And for others, one set of permission. This is what I'm planning to have. Now, how can I apply this permission on any file? For example, I'm having this file called hard. So you see on this file, the user or creator is having read write permission, group is having read permission, and rest of the other world, all other users, all other groups that might be there in the system, they can have only read permission. So I want to change it according to this requirement. So in order to totally modify the permission, you can go with the command chmod, change the mode, and you have to say for user you want to set read, write, execute permission. Now it is not done yet. I have for group also and others also. So you have to give a comma. For a group, you have to give G equals to. For a group, I want to give read and write permission. Then for others, I want to set read permission. On which file? The file name is hard. So I'm telling change the type of permission, this for user, this for group, this for other, on a specific file whose name is hard. Now you run ls-l and hard, you'll find that first three permission is for user. What's the permission? Read, write, execute. The next three permission is read, write without any execute permission. So we have said that. And last permission is read. So as per your requirement, whatever permissions you want, This is the way you can set the permission. For user, what permission, group, what permission, and for others, what permission you want to set it out. Okay, all right. Now let us say that I don't want to change the permission completely.
Uh,
Maybe on,
One second. Here you said that it has been changed, but I can see the color is changed. Hard.
so whenever you modify the file permission, that color might get changed. And how that color is affecting? Observe here. Don't observe the color. Is it changing or not?
Yes.
Previously it was different, now it is different. So let's concentrate there. Ignore the
Okay.
color coding. I told you that there are many Unixes which does not follow color coding. Then okay.
Okay.
So as I was telling you that the file permission is now modified. Let us say I don't want to totally modify the permission. My requirement is I just want to add or remove a permission from existing permission. For example, you see on user level, we have given read permission also, write permission also, execute permission also, right? From that read, write, execute of user, I want to take away one of the permission. Maybe on the user level, I don't want it to have execute permission. So I am not interested to modify total permission. From user, I want to take away one permission. That's it. So in order to target only one level, you have to say chmod from user what you're planning to do. Are you modifying the total permission? Or you just want to add or remove one permission. I want to add or remove one permission. So if you are adding a permission, you have to say plus. That means on user, add this permission. Or if you want to remove the permission, you have to say u minus plus when you want to add a single permission minus when you want to remove a certain permission from user. So I'm telling that from user, take away minus the execute permission on which file? Hard file. Now, if you just check it out over here, you see read, write, and there is no execute permission, right? And obviously that color might be changing because for script we need execute permission, and whenever you give execute permission, you might find that the colors might be changing. So ignore color coding, concentrate over here that what permission we wanted is assigned or not. So you see, I told that just from user, take away execute permission, and exactly the same thing happened. From the user, execute permission is gone. Now let us say I want to do two things. On group, I want to remove write permission. And for others, I want to give execute permission. You see, for group, we have write permission. I want to remove that. And at the same time, for others, I want to give execute permission. So one level, I want to remove the permission. Other level, I want to add a permission. So one level, I want to minus something. On the other level, I want to plus something. So how can I do two things? You can say chmod from group, I want to minus write permission. So from the group of the file, I'm taking write access. Then you have to give comma. And for others, I want to add execute permission. On which file? On hard file. So when you see the file permission now, you will find that earlier on the file there was read write permission. Now it is only read permission. And on the group there was just read permission. But now you see read and execute. Both permissions have been assigned. So like that, what you can do, You can add something on one level and you can remove something on other level. Or in fact, you can give common permission for all and you can remove common permission from all. For example, what I want to do is I want to remove read permission from everyone, from all. That means from user level, group level, others. From all, I want to take away execute permission. So how can I do that? You can say chmod from user, group, and other. You go means user, group, and others. From all, I want to commonly minus read permission. From which file? The file name is hard. Now, if you just check it out, none of them is having read permission. From all level, I took away read permission. Same way, you want to give all of them read permission again. So you can say chmod ugo. I want to add read permission. From which file? The file name is hard. Now you just check it out. See, user is having read permission, group is having read permission, others are also having read permission. So this is the way you can modify the file permission. In fact, if you want, you can give full access on the file. That means read, write, execute for user, read, write, execute for group, and read, write, execute for others. That is called as full permission. So if you want to give full permission on every level, then you can say chmod for user, group, and others. For all, I want to modify complete permission. To what? Give everyone read permission, write permission, and execute permission. On which file? The file name is hard. Now, if you just look it out over here, you see for everyone, read, write, execute for the creator or user, read, write, execute for the group owner, and read, write, execute for rest of the other world, all other users, all other group in the system. For everyone, we wanted to give full permission. Now this file has full access. Anybody can read in this file, anybody can write in this file, or if it is a script, anybody can run that script, right? So that is how you can modify the permission on a file, or it is a directory. It is almost same. One small difference is there on a file or a directory. I'll tell you what is that, right? Now moving ahead, what is the absolute permission? Here we have learned symbolic method. Next we are going to learn absolute method, or which is also called as numeric method, with the help of numbers. Now guys, both methods are important. You should not come to a conclusion that symbols are there UGO, so that is important, or here numbers are there 421, so this is important. We use that also, we use this also. Both methods you should learn. What you apply, that is your choice, but both methods are important. Both methods are very, very useful. See, whenever you are trying to add or remove single permission, UGO, that is very important. And whenever you are trying to modify total permission, absolute method is very important. So in absolute method, instead of calling read, write, execute, we denote it with some number. We don't go with RWX. Here, read is represented by 4, write is represented by 2, and execute is represented by 1. Read, write, execute. 4 is for reading, 2 is for writing, and 1 is for executing. Remember that 4, 2, 1. That is the thing what we have to remember. Okay, right. Now how these numbers will help us to assign the permission. Let us calculate it. Same scenario is there. For user, I want to apply read, write, and execute permission. So read is represented, let me put it little down. Read is represented by 4, write is represented by 2, and execute is represented by 1. So you see, you have to club them, you have to add them, you have to sum of them. You have to say 4 plus 2 plus 1. What's the result we will be getting? The result is 7. Same way, when you just want to go for read and write means 4 and 2. So you have to add them. 4 plus 2 is equals to how much? 6. Then when you are going only for read, you have to go with what? You have to go with 4. 4 means you don't have to club 4 with nothing. You just need to give 4. So the final number what I'm getting is 7, 6, 4. So 7 means what? 4 plus 2 plus 1. That is nothing but read, write, execute. 6 means what? 4 plus 2, where 4 is read and 2 is write. And again 4 means just read. So the final number what I got is 7, 6, and 4. So let us change the permission on the file and see how it works. Before that, guys, I'm really sorry. I also need to show you one more thing. Suppose on this file, I want to remove all permission. There are some special files in the system which we will see. When we go for Linux administration, I'll show you that there are few files which does not have any permission. So sometimes we have to remove the total permission from the file. So if you don't want any permission on the file, there's one method you can say ugo is equals to no read, no write, and no execute permission. On which file? Hard file. Now if you just check it out, it is coming complete dashes. That means no read permission for user, no read permission for group, no read permission for others. Neither you have write permission nor you have execute permission. So all empty, no permission. So like that, you can remove total permissions if you want. Now let us come back to our topic, what we were talking about, the number. The number what we have calculated is 7, 6, and 4. So let us apply that permission. I'll say chmod 7, 6, 4. Now don't club these numbers. Don't try to add 7 plus 6 plus 4. That is not going to work. Separately, you have to give 7. 7 is for user, 6 is for group, and 4 is for others. On which file? The file name is hard. Now when you run ls-l, you see for user it has given read, write, execute. For group, it has given read and write, and for other, it has given read. So guys, whenever you are trying to totally modify the permission, don't you think that this number is simple to give instead of giving u equals to something, g equals to something, o equals to something. Instead of that, giving such numbers are quite simple. Very simple. So you can go with different calculation, whatever you want. For example, you only want read and execute permission. That's it. So what you can do, you can say 4 plus 1. So it becomes what? 5, right? You want write and execute permission. So you can say 2 plus 1. Like that, 2 plus 1 will become what? It becomes 3. And lastly, I wanted to give only execute permission. So you can say 1. So maybe you can try that way also. 531. For example, I'll say chmod 531. On which file? Hard file. Just check it out. Read and execute for user, write execute for group, and only execute for others. So whenever you are totally modifying all set of permission, numeric method is very important. Whenever you are adding single permission, let's say for user execute, that's it. Or removing a permission from group, minusing execute permission. In that, symbolic method is important. Adding individual permission, symbolic method. Totally modifying the permission, numeric method. For example, you want to give full access to the file. Read, write, execute to everyone. So you can say chmod 7 for user, 7 for group, and 7 for other. What is 7? 4 plus 2 plus 1. That is read, write, execute. On which file? The file name is hard. Now you just check it out. Everyone is having full access. Read, write, execute, read, write, execute, read, write, execute. Right? Or let us say you want to remove all permissions from this file. So you can say what? Chmod 0, 0, 0. No read write execute, no read write execute, no read write execute. On which file? Hard. Just check it out. You see it has zero out the permission. So whenever total permissions of the file you are modifying, numeric method is very important. Adding, removing individual permission to a file or directory, then you can go with absolute methods, whatever we have learned with. Okay, all right. So this is the way you can apply the permission. Now, as I was telling you, on a directory, there is one thing extra what you can do. See here, I have a directory, my dir. How to check the details about a directory? You have to say ls-ld. List in long form the details about directory my dir. And if you want to see what is inside this directory with their permission, you can say ls-l, the directory name. So you see it says that on the top of directory, I have this permission. And in this directory, I have three more directories, three more files, which is having these permissions. See, my requirement is I want to change the permission on the directory and all the content inside it at the same time. Same permissions I want to give on the directory and the files inside it. So how can I give same set of permission on the directory and all the files at a time? You can say chmod hyphen capital R. Capital R stands for recursive. See, I already told you about recursion. Recursion means it goes inside the directory, and if there is subdirectory, it will go inside it. If there is anything else, it will go inside it. So going from top to bottom inside the directory, inside it is nothing but recursive or recursion. So whenever you go from top to bottom, you have to go with recursive option. So I'm telling that recursively from the mother directory to the deepest child that is available inside the directory, for all I want to give recursion. So I'll say recursively everything, whatever is there in the directory, apply this permission. For example, I want to give 764. Maybe some permission I want to give like this, or you can say u equals to g equals to o equals to whatever you want. On which directory? The directory name is my dir. First of all, you check the directory permission. So you see read, write, execute, and read permission. That is what it has assigned. Now check all the files inside it. You'll find same set of permission it is getting, right? So whenever you want to give same set of permission on the directory and all the files inside it, then you have to go with capital R. Capital R is only workable on the directory because recursive can only be worked with directory. When you have something in the directory and all the files inside it, you want to give same permission, then you will go with capital R, that is a recursive option, right? So this is the small difference between applying the permission on the file and applying the permission on the directory. So whenever you want to change the permission for directory and the content, you have to use capital R. If you don't want to change the permission on the content, don't use capital R. Capital R will also change the permission inside the directory, whatever files are there. Okay. So this is how we apply file permissions. Now one more thing. See, normally we create some file. For example, I'll create an empty file with a name called XYZ. Now when I create this file, you see not only file is getting created, but you see it is getting some permission. Guys, I ask it to create a file. It created. But did I ask it to give some permission also? No, I simply ask a file to be created and file got created. How come the file is getting this permission? I did not give any permission from my side. I did not told that user should have read write, group should have read, and others should have read. This is called default file permission. Whenever you create a file, automatically the file will be getting some permission which is called as default file permission. Excuse me. So as I was telling you that a file will get automatically some permission at the time of creation, which is called as default permission. Now my question is, who is deciding that default permission and why it is getting read write read read only? Why not anything else? Let us find out. See, we have one concept called UMask. See, UMask stands for Unix File Creation Mask, right? So this UMask will decide what default permission a file or directory will be getting whenever you create a file or directory. So when you run just UMask command, it prints some value 0022. What is this 0022? Let us find out, and let us also find out that how this UMask is deciding the default file permission. See guys, we have to do small calculation over here. Let's find out default file permission. See, maximum a file can get a permission is 777. We just saw. Full permission means 777, all heaven. Right. But there is a rule in entire Unix, not only in Linux, in entire Unix, there is a rule. And the rule says that by default, a file will not get execute permission. See guys, it's a protection against viruses, malware, and spyware kind of thing. See, these viruses, malware, spyware, they comes to your system in the form of script, and a script require execute permission. So by default, if I don't give execute permission, then automatically on its own, the file will not be executed, right? So that is a protection for your viruses and kind of thing, that a file will not be getting execute permission. When you create a new file, it won't get execute permission by default. When you download a file from internet, it won't get execute permission by default. So whenever any alien file that is coming to your system, it won't get by default execute permission. That is a protection by Unix and Linux. So by default, it is not possible that your file should get execute permission. If you want, you can apply execute permission later, but by default, the file will not be allowed to have execute permission. Keep that in mind. So what is the maximum permission your file can get? It can get 666. That is the maximum permission your file can be getting. Now from the total permission, when you minus the umask value, what is the umask value? 0022. Now I would like to request you to ignore that first zero and concentrate on last three digits. What is that first zero? We will understand when we go for user admin class. As of now, you just concentrate on last three digits, that is 022. So let us say that the umask value is 022. Now if you do minus, what's the result you'll be getting? We'll be getting 6, and 6 minus 2 4, 6 minus 2 4. So what is this number? How it is representing? See, 6 is equals to, let me put it this way, 6 is equals to 4 plus 2, isn't it? Right? That is nothing but read and write. Then just 4 is equals to read, and last 4 is also is equals to read. Remember that 4 to 1 concept. So by default, when you create a file, you will be getting a permission read write, but no execute permission. Then for group, you'll be getting read permission, no write, no execute permission. And lastly, for others also, you will get just read permission, no write, no execute permission. So by default, this UMask is deciding that whenever a file is created, by default, the file will get this permission, read and write for user, read for group, and read for others. Are we getting the same set of permission here, guys? Observe when I created the file, right over here, read write for owner, and read permission for group, and read permission for other. Is it the same thing what we have calculated? Yes. So when total permission gets subtracted with umask, you'll be getting your default permission. This is how default permission is set. This is a default permission for a file. Let us find out what is the default permission you will get for
Sir,
a
sir,
directory.
excuse me.
Yes, Hamid.
Please, can you just go over this particular one again, please?
See, a total permission a file can get is 777. And there is a rule in Unix that by default, a file cannot get execute permission. So we have -111. That means the total permission now you can have is 6, 6, and 6. So from that 666, when you minus the umask value is 022. So 6 minus 0 will be 6, 6 minus 2 will be 4, 6 minus 2 will be again 4. 6 if you open, it becomes 4 plus 2. 4 means what? Read. 2 means what? Write. Then again 4 is what? Read. Again 4 is what? Read. So by default, the permission that you can get when you create a file is read write, read, and read. That is what you got. When I created the file, by default, I got the permission read write, read, and read. So when the total allowable permission you minus umask from the total permission, when you minus the umask permission, it gives you the default file permission of your system.
Okay, I guess is the UMax that I didn't really, sorry, maybe I was a little bit distracted. I
Okay.
didn't see the UMax. What does the UMax mean? And the UMax is like,
Unix, Unix file, Unix.
sorry.
Can you mute yourself? Unix file creation mask. So that mask will get subtracted from the total permission to give default permission. Whatever total permission can be, from that total permission, when you minus the umask permission, it give you the default permission. Let me complete myself, then I'm sure that it would be more clearer. What would be the default permission for a directory? See, last time we found out the default permission for a file. This time, let us find out what will be the default directory permission. So the total permission can be 777. Now guys, for a directory, there is no rule that execute permission should not be given. Directories are not scripts to worry about. So for a directory, you can get execute permission by default. There is no restriction. Like we have a restriction for file, there is no restriction for directory. For a directory, you can have execute permission by default. Nothing problematic about it. So directly from 777, I'm going to minus 0 to 2 minus the umask permission from total permission. So I'm going to subtract it. So what would be the values over here? It would be 7. 7 minus 0 is 7. 7 minus 2 is 5, and 7 minus 2 again is 5. So what would be the permission over here? Let us calculate. 7 means what? It is 4 plus 2 plus 1, isn't it? So 4 means what? Read. 2 means what? Write. And 1 means what? Execute. Then next we are having 5. 5 means what? 4 plus 1. So where 4 means what? Read. 1 means what? Execute. Same thing again we go with 5. 5 means again same, 4 plus 1. That is read and execute. So whenever you create a directory, the default permission would be read, write, execute, read, no write permission and execute, read, no write permission and execute. That means for owner, you'll get full permission. For group, read and execute. For others, read and execute. Let me quickly create a new directory and show you the permission. I'll say mkdir. To make a directory, we have a command make dir. We learned that. Now I want to create a directory with the name called testdir. Just check the permission of testdir. You'll find it exactly the same thing what we have calculated. See, for owner, it is read, write, execute. For group, read and execute. For other, it is read and execute. Exactly the same thing what we have calculated. From the total possible permission, when you minus the umask, you are going to get default permission for the file or default permission for the directory. Okay, so umask will decide that what is the default permission your file or your directory will be getting. Now the question is, can we change the umask, or changing the umask value is a good practice or not? See, normally in most of the working environments, we don't touch the umask value. We don't change it. We are okay with whatever default permission it is giving us. But if you think for your environment, you don't want the regular default permission, you want something different, then definitely you can change the umask value with your requirement. You have to do this calculation and come to a conclusion that what umask value you want. For example, I'm changing it randomly. I'm just changing it. To change the umask value, you have a command umask again. The current umask value is 022. I want to change it to 002. Instead of 022, I'm making it 002. So now you see the umask value is changed. Instead of 022, it is getting 002. So when you change the umask value, automatically default permission will also change. So 666 minus 002. 002 means you'll get 6, 6, and 4. So when we go with 6 and another 6, 6 means you have to go with 4 plus 2. 4 plus 2 means read and write. So now onwards, whatever file you create, it will get read, write, and read. For example, let me create a new file, n1. Now you just check the permissions of N1. Is it getting the same read, write, and read, right? So this is the way how we have to change the umask value, and whenever you change the umask value, default file permissions will always be affecting. Now same way if I create a directory, so it would be what? 002 minus 002. So it would be 7, 7, and 5. And we know 7 means 4 plus 2 plus 1. So it would be read, write, execute, read, write, execute again, and then read and execute. Let us create one directory. I'll say mkdir d1. Now just check the permissions of d1. Is it getting the same thing? Read, write, execute, read, write, execute, read and execute. So your umask value will always affect what default file or directory permission you will be getting. So whenever you change this thing, automatically it is going to be affecting the default permission. Whatever files previously created will get different access according to that time. But after changing umask, whatever files you are creating will get this new default permissions. So default permissions will be affecting when you change umask value. And guys, you can play with umask whatever you want to change it, but make sure once your work is over, please reverse it back to 022, right? Normally, as I told you, we never disturb the umask value. In few organizations, if it is required that you don't want the default permission as a default option, you want to make it as per your norms, then you can set whatever default umask value you want. So you can change it to whatever you like. But once your practicals are done, your experiments are done, revert it back to 022. Let it be followed what we got by default when we install the operating system. So this is how a file permissions can be modified or default file permission can be set. Now last thing what I want to show you here is how to hide and unhide a file. See, let us say that I have a file here called hard. Now maybe I want to hide it. I don't want people to see that. See, whenever you want to hide any file, just change the name of the file. How to rename a file? I'll say MV. The current name is hard and just rename it with a dot. So whenever you create a file or change the name of the file with dot, the file will be hidden. Now if you do ls, do you find any more hard file? Previously there was a hard file, but when I rename it, are you able to find any hard file over here? No. Then the question here is, how can I find? Is there any hidden file? To see all the files, even though if it is hidden, you can use a command ls-a. A stands for show me all the files. So over here you see whatever files or directories that are starting with dot, These are nothing but hidden file. So in this list, you can also find that there is your file hard. If you want to unhide it again, then you can say mv, change the name of .hard to simply hard. Now you do ls. Did you find your hard file back? Same way you can hide or unhide a directory. I have a directory mydir. To rename it, I'll say mv, change the name of my directory and put it with .mydir. Now when you do ls, last time there was a directory my directory, but now is it available anymore? No. Where is it gone? Check by ls-a, you'll find it is hidden. How to unhide it? You have to again rename. You have to say mv, change the name of .mydir to simple mydir. Now you do ls and you'll find my directory is back. So that is all guys related to your basics. So today we have complete the entire Unix basics classes. Tomorrow onwards we are going to start working with our first chapter in Linux administration, that is performing partitioning and all other activities. Now so far if you have any questions or doubts, you can put your questions now. I'll be trying to answer and clarify your doubts.
Related to user administration,
Hmm.
this is today we saw the file permission, right? So
Hmm.
user administration, we have user add and some user, how to add groups and create users.
So have we covered user admin class, Abdullah?
No, does it comes under this session or it is a separate session?
That is a separate session. User administration itself is a separate topic.
Okay.
But we're gonna learn it under Linux administration, right?
Yes, under Linux administration, we are going to cover up that. See, we have already shared the course content. So in that, you can also see the topics. You have a manual with you. In that also, there is a topic. Usually user and group administration comes under delegation part. That definitely covers under Linux administration. How to create users, modify, delete, group creation, modification, all that thing. These are general basic things what we have covered in Unix basics, right? Yeah, Manoj.
Yeah, the if I want to search a file with the keywords like you say you search for something like say Linux, right? So
Hmm.
if I want to search with a keyword like if I yeah SE, so in that case, how can I find using Python?
Starting with SE, you're telling like that.
Yeah, yeah, yeah.
Okay, so you can say find in the whole system a file with a name starting with SE. After that, it can be anything. So star makes anything after that. So initial words should be SE. After that, it can be anything. So when I
Yeah,
hit enter, it's going to search all the file that start with SE.
yeah, understood. Okay.
Or you
And,
are sure that there are only 4 letters inside it.
yeah,
So you can say, for example, I want to search a file starting with my and next 2 digits only or 3 digits only. So you can do 3 question marks. So you see my dir like that. But if you are not sure that after that how many characters are there, then you have to give star. So it
yeah,
can be 4 characters, 5 characters, six
correct.
characters, what like that. So anyway, it says that there are no such characters. Anyway, if the file is does not find, sometimes it may give this error. Do not worry about that.
So we can search it again.
Yeah,
So if
or
you
you
are
can
if you
start
are in
m star.
if you are if we are in other user like other user folder, the root, can we use the same command?
Your non-root, no problem. You can search it. It might search, but some results might not display. Root has power to go everywhere. Other
Yeah,
people can see most of the cases, but you cannot go into that locations.
yeah, okay, got it.
Yeah,
Thank you.
you're welcome, Manoj.
Sorry. Now the U mask. If
Hmm.
we want to use it in real life, using it in a job environment, so you can use it when maybe you are starting up a project and you want to start creating your folders, and you don't want any permission to be tagged wrongly to different folder. That's where you can use it, right? Or
See, UMask affect the entire operating system's permission. It is not for an individual folder or individual directory. So whenever you change the UMask permission, whatever new files that are going to get created will get the permission what you desire. So if your requirement for your organization is that there should be no read permission by default, then you have to calculate the UMask value and set. So whatever file that would get created will never get read permission by default. You want to give it, you have to give it manually.
oh, okay. Thank you for that clarification.
Hello, sir.
Yes, Prasad, tell me.
Sir, today I joined to new class today.
Okay, one second.